All right, let's pull back the curtain on one of the most important inventions in history, the car engine. We're going to break down exactly how this incredible machine turns a drop of fuel into pure motion, all starting with just one tiny spark.
You know the feeling. You press the gas pedal and the car just goes. But have you ever really thought about what's happening under the hood? What's that incredible, intricate dance of metal, fire, and air that makes it all happen? Well, that's exactly what we're going to dive into.
To really get a grip on the whole engine, we've got to start small. Super small, actually. We're going to start with its single most fundamental part, the piston. From there, we'll build our way out, piece by glorious piece.
You see, at the very heart of the engine, there's this constant, repeating rhythm. It's called the four-stroke cycle, and it's basically the heartbeat that every single piston follows.
So first things first, what even is a stroke? It's really simple. It's just one full trip the piston takes, either all the way up or all the way down, inside of its little home, which is called a cylinder. 4 of these simple movements create one complete cycle of power.
So let's follow that rhythm. First up is intake. The piston drops down, and in doing so, it sucks in a perfectly mixed vapor of air and fuel. Next, compression. It shoots right back up, squeezing that mixture into a tiny space, making it super volatile. And then comes the magic moment. Power. Bang! A single spark ignites the mixture, creating a controlled explosion that slams the piston down with incredible force. This is the moment that actually moves your car. And finally, exhaust. The piston rises one last time to push all the spent leftover gases out. Intake, compression, power, exhaust. And get this, that entire dance happens thousands of times every single minute.
Now, as you can imagine, a single piston firing all by itself would make for a really jerky ride. So to get that smooth, consistent power we're all used to, engines use multiple pistons, all working together in perfect harmony. Let's see how they pull that off.
Now here's where things get really clever. In a typical 4-cylinder engine, you'd think the pistons would fire in order, right? 1, 2, 3, 4. But nope. Instead, they use a firing order something like 1, 3, 4, 2. And why on earth would they do that? Well, this specific sequence is an engineering marvel. It's designed to perfectly balance all those explosive forces across the engine, which prevents it from shaking itself to pieces and gives you that smooth, stable delivery of power.
So how does the engine keep this perfect beat? Well, it's kind of like a mechanical orchestra. You have camshafts that push the valves open at the exact right millisecond. There's a timing belt or chain that acts as the conductor's baton, linking everything together so no one misses a cue. And then there's the crankshaft. This is the star of the show. It catches all that up and down force from the pistons and brilliantly translates it into the rotational force that ultimately turns your wheels.
And that right there perfectly explains what RPM actually means. When you look at that tachometer on your dashboard, you are literally counting the number of full 360-degree spins that the crankshaft is making every single minute. Pretty cool, huh?
Now, while that 4-stroke principle is basically universal, engines can be laid out in different ways. You've got your inline engines, where all the cylinders are just in one straight line, and then you have V-shaped engines, like a V6 or a V8, where the cylinders are split into 2 angled banks. It's all about fitting more power into different size spaces, and it's also a big part of what gives different engines their unique sound and feel.
Okay, so we've pretty much built the core of the engine. But just like any living thing, it can't survive on its own. It needs this whole complex network of what I like to call life support systems just to keep it running. First off, the engine needs to breathe, and the air intake system acts as its lungs. It pulls air in through a filter to get rid of all the dust and gunk. From there, the intake manifold makes sure that each cylinder gets the exact gulp of air it needs for combustion. All right, if it's breathing, it also has to eat. And the fuel system is like its digestive tract. A pump sends gasoline all the way from the tank through a filter to these amazing little things called fuel injectors. They then spray a perfectly fine mist of fuel into the air coming in, and precision here is absolutely everything if you want good power and efficiency.
All those thousands of tiny explosions create a massive amount of heat. So to keep the engine from, melting down, the cooling system is constantly at work. It circulates a special liquid called coolant through all these channels around the engine, soaking up heat. Then that hot liquid goes to the radiator at the front of the car, where airflow cools it down before it's sent right back to do it all over again.
This right here is the engine's nervous system. The battery gives it that initial jolt to get started. The alternator acts like a little power generator, creating electricity once the engine is running. The spark plugs, of course, deliver that critical spark. And overseeing this entire operation is the ECM, the engine control module. It's a tiny computer, and it's the real brain, managing timing, fuel mix, and dozens of other things every second.
With so many metal parts moving at incredible speeds, friction is the ultimate enemy, and the oil system is the hero. It pumps motor oil all throughout the engine to lubricate everything, keeping it all moving smoothly. Without it, the heat from metal-on-metal contact would cause the parts to literally weld themselves together, seizing the engine in seconds.
And finally, the engine has to exhale. The exhaust system collects all the used-up gases, sends them through a catalytic converter to neutralize the most harmful chemicals, and then through a muffler to quiet down the noise before finally releasing them into the air.
So, we've seen the core rhythm, the synchronized parts, and all the essential life support systems. Now, let's put it all together and see the final machine in action. And there it is. The breathing, the feeding, the cooling, the thinking. It's a mechanical symphony. Every single component we've talked about, from the smallest piston to the complex computer brain, all working together in perfect harmony to create controlled, sustained power.
You know, it leaves you with one final thought. When you look at this whole incredible machine, what's really more impressive? Is it the sheer, raw, explosive power it can generate? Or is it the microscopic, split-second precision and timing that's required to control it all? Something to think about the next time you turn the key.